Bismillah ar-Rahman ar-Rahim. In the name of Allah, the most gracious, the most merciful. Welcome to another lesson. Welcome to Lady Khadija radiallahu anha online college. May God be pleased with her. Live lesson in A-level maths, year 2, pure maths. Today is continuing from the last lesson where we're trying to substitute into a binomial expansion. If you're following through in the book, then it's chapter 4, example 3 of the Pearson EdXL UK A-Level Year 2 book. Okay, let's begin. Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful, with just a quick look at the question we started from last time, from the last lesson. It's expanding 1 minus 2x all square rooted up to and including the term in x cubed. So that was the work we did last time. We start with the binomial expansion formula. This is the formula you use when the power is a fraction or a negative number. And one, so it's quite easy to start off with 1 plus nx and then plus, and then the x squared and x cubed terms, they start using fractions, which hopefully you get the pattern. It's 2 factorial for the x squared term, 3 factorial at the bottom for the x cubed term. And we saw more about that. We talked more about the formula last time. So by now you should be comfortable using the formula, and we did use the formula last time. Here the x gets substituted for whatever is at the end of the bracket. So in this case, minus 2x. The square root gets rewritten as the power half, and then it's just a case of putting it into the formula and simplifying, which we did up to here. So now we're ready, and the question says substitute in x equals 0.01. So the question is substitute it into what? Do we substitute it into our answer here? Do we substitute it into the original expansion that we were trying to do here? And the answer is both. What we're saying is that this original question, square root of 1 minus 2x, apart from changing the square root to the power half, we can just leave it as the square root. And we're saying that this I just need to bring that back up. So we're saying that this square root version of the question can be rewritten, can be expanded out to this 1 minus x minus half x squared minus half x cubed. And there are more terms, but we just didn't do them. We just stopped it at x cubed because really for most purposes that's enough. So because it's not completely the answer, that's why it's used the word approximation, but it'll give us close to what we need, even without the x to the power 4 term, x to the power 5 term. Those terms would finish the expansion or would carry on the expansion, but up to the x cubed term is approximately right. So now we need to substitute in x equals 0.01 into the thing we were trying to expand, as well as our answer that we've got up to the x cubed term. So let's do that. So we've got the x equals 0.01 going into here. So that would become the square root of 1 minus 2 times 0.01. 2 times 0.01 is just 0.02. So it's 1 minus 0.02. And that is just 0.98. So I can rewrite that as 0.98. And then if you want to think what happens next, So then what happens is that we want to carry on with the substitution, but after the equal sign, we will have the 1 just stays as 1, minus x now becomes minus 0.01. Then we've got minus a half x squared. So x is 0.01, so it's minus a half times 0.01 squared minus, and then the last term is a half again, and this time it's 0.01 cubed. And then you just want to type that all into your calculator on starting from the 1 and see what it gives you. The left-hand side, you don't want to type it into your calculator, you just want to leave it as it is. It's only the right-hand side that you want to type in. So the right-hand side should work out to be 0.98 99495 dot dot dot. There are more numbers to that, but that's good enough. So now, actually, I think that's the exact answer there, so that's fine. So now, what was the question? The question didn't just want us to do the substitution. That was the first bit of the question. The real question was find a decimal approximation to the square root of 2. That's what we're really trying to find out, is a decimal number that we can say is very, very, very close to the square root of 2. So just remember that at the moment we've got the square root of 0.98 is very, very, very close to 0.9899495. You could even try that in a calculator if you want. If you were to type that in, square root of 0.98, you would get something very, very similar to that. Like I said, we're missing the x to the power 4 and x to the power 5 terms, so we're not expecting a perfect answer, but that would be very, very close. So now how do we get it so that instead of the square root of 0.98 and a decimal, I've got the square root of 2 equals a decimal. So this is where you really need to just have to play around a little bit, think a little bit, think about what you're seeing here is the square root of 0.98 and ask yourself, how can I make it look like something like the square root of 2? It doesn't have to be exact, but it has to have a 2 in it and it has to have a square root in it. So the first thing you're thinking of is, well, hold on, 0.98 is very close to 100. In fact, it's so close to 100, it's only 2 away from 100 if that was a 98. So then you're thinking, okay, how do I turn that into a 98? So then you can think, well, 0.98 is really 98 over 100. So that's what we can do. We can change 0.98 to 98 over 100. And now we can say the 98 is, apart from it being 2 away from 100, now the problem with that is that then you get a minus, and square roots and minus signs underneath don't really go well. So we need to find another way of getting that 2. So the other way of getting that 2 is you think, well, hold on, 98, are there any square numbers that go into 98, particularly when I'm timesing by 2? And the answer is 98 can be rewritten as 49 times 2. 49 times 2. So 98 can be halved, or it can be written as a times 2 as 49 times 2. And now, because everything underneath the square root is either a times or divide, there's no adds or minuses, then it becomes very, very easy to split. that square root can be applied to each bit separately. So we can write this as the square root of just 49 times the square root of just 2. And you can guess on the bottom what I'll have. It will be the square root of just 100. And on the right hand side, I'll have what I had before. I haven't touched that decimal, so that can just stay as it is. And then look back, we just want the square root of 2 on its own. We just want the square root of 2 on its own. So that means I can take the square root of 100 to the other side, the square root of 49 to the other side, and I'll be done. So if I just make myself a little bit of space, the square root of 100 can come to the other side, so that's times by square root of 100. And the square root of 49 can come to the other side, so that'll be a divide by square root of 49. And then there's only the square root of 2 left on that side, so that's all I need. I can get rid of everything else. And then you just need to type that into your calculator. So 0.9899495 times square root of 100, you already know is 10, so I can straight away write that in. So that can be rewritten as 10. And the square root of 49 below it can be rewritten as just 7. So that's what you type into your calculator, nice and easy, 0.9899495 times 10 divided by 7, and that will give you 1.414213571, and that is your decimal approximation to the square root of 2. Okay, join me again tomorrow for more on binomial expansion. We're working through the chapter. Assalamu alaikum wa rahmatullah. Peace be with you, and the mercy and blessings of